So for the test, I'm basically taking this problem, and I do want you to find a number of ants, like a calculation. You have to find the formula, but I also want you to find the growth rate on a given day, like how many ants are actually growing on a given day. So I'll go over that. So we have Ryan spills some soda and neglects to clean it up. He leaves for spring break. Okay, upon returning 17 days later, Ryan counts 3,960 ants, and the next day there are 5,280. So we want to come up with an equation. Okay, I like to think of it again in terms of a t-table. I knew on day 17, we'll call it day 17, there were 3,960. And the next day, so day 18, there are 5,280. All right, so we need to find a growth rate here, or your common ratio from day 17 to day 18. So to do that, we would divide 5,280 divided by 3,960. Okay, so we divide that, and we got 1.33 repeating, or 1 1/3. Okay. Now, there's a couple ways that we can write this function. This one's kind of tricky because we're talking all the way about day 17. Okay. So what I would do is it doesn't give you an actual, it doesn't say you have to have your starting time or day 1 or day 2 or day 0 in your equation. So what I would do is I would say, okay, let me go f of t, and I would start at 3,960. All right, I know my growth rate is 1.33 repeating. Now the trick is, what do I put as my exponent?
Negative 17.
Ooh, I like this idea. I want that because when I plug a 17 in,
It'll be 17 days after.
yeah, when I plug a 17 in here, I want it to be 3,960. So I think what I would do is put in a t minus 17 as your exponent. So notice something here. Usually you start this right here is day 0. That's what we started off by learning. But if whatever day we start here, we could put t or n minus that number up here for the day, because now if I substitute a 17 in for t, this becomes 0. That 1.33 up to the 0 power is 1. So I'm good, 3,960. So that would be fine for your function. Now it says to calculate the number of ants Ryan saw when leaving for spring break. So this becomes kind of a question of, did he see this at the end of the 17th day, at the beginning of the 17th day? I mean, there's a kind of a general idea there. I'm just going to call when he left for spring break day 0. Okay? So that was after one day would be the next day. So if we substitute a 0 in here for t, we would get what he would have when he left for spring break. So that's answering the question that they want you to answer. Bless you. Okay, so you're substituting in there, you get 29.76 ants. Now you can't have 0.76 ants, so you can say 30. Say 30 ants, 29 ants. Okay, the whole idea is we understand that idea. Okay, so now the question would be, I could ask, what is your growth rate on day, 25? Okay, how many ants are you growing by? So don't mix this up with what your percentage you have. So here, we're gaining, right, 33% per day. Okay, but I actually want to know how many ants are we increasing by on the 25th day. That makes sense? So let's go here.
Why do you want to know the 25th day?
I'm just making that one up.
Just because you do?
Just because I do. So how many ants do we increase by on day 25? Okay, so there's a big difference here in what I'm saying, because this one right here, you're gaining a 33%. You're gaining 33% ants, but I'm actually increasing by whatever the difference is here. What's that, like 1,300 or so? So I want to know what the increase in ants are, because 33% is different every day. It's going to increase. So how you would do that is I'm going to use my formula that I had right here. T is time. So what I'm going to do is I'm going to substitute in, and I'll put it all in one formula. But if I do this, and I'm going to put 25.01. So if I plug in 25.01, I'm basically finding the slope of that line, right, at day 25.
Where did you put 0.01?
Because I'm going to subtract now
Oh,
the same thing. Oops. That should have been a 39. Sorry about that. I'm going to subtract when you substitute a 25 in there. I'm going to divide it by the difference in my x's. So really what I'm doing is these are my y values, right, or my f of t values, with both 25.01 and 25. And then I'm going to subtract those two values and then do my change in x, which is just 0.01. I get that from subtracting the 25.01 minus 25. And if you do that, you're basically getting your slope of your line. If my graph looks something like this, and day 25 is over here, I'm finding my slope of my line at day 25. And that slope would be your increased number of ants on that day. Did anybody come up with an answer yet for that?
just gave me a weird look.
That seemed like a big number, but what was that again? 11,000.
72. Oh, 72.
Okay.
0.486.
Put 49. So that should be, on day 25, how many ants you're increasing by, like the actual number per day. So on day 25, you should have increased by about 11,000 ants. And that seems like a high number, but if I think about this, 18, on day 17 it increased to 18, it increased by about 1,300. And then you're going to get a bigger number there, so it increased by 33% more and 33% more. It should get pretty big. Yes?
Did you just choose 25.01 because it's close to 25?
Yes.
Okay.
Yeah, so I wanted to increase on day 25, so I used day 25, and then I used a number a little bit bigger than day 25.
Okay.
So that way I'm pretty darn close to finding my slope at 25. Okay.
Shouldn't we do like 24, 26 because then it's an entire day?
You could, but if you have a graph, you could use 24 and 26, and it might be pretty darn close then. And yeah, you're bounded in the middle. But if I make it, the smaller I make it, the better it should be. And typically you just start at the day that you have, and then just go a little bit higher.